All right. So skill 5 is to divide algebraic fractions. And um, if you recall me saying early in the semester when I talked about fractions, in algebra you typically don't see that divide sign, right? You don't see this division sign like you do in basic arithmetic. What you see is complex fractions, right? And this this fraction bar essentially means, so like for this first example, it's x plus 5 over 7x cubed, and that whole thing is divided by this other fraction. All right, so we have fractions within fractions, which is kind of ugly. So, but this is just a division of two fractions, okay? You're just dividing the numerator by the denominator. And the same rules apply to algebraic fractions as regular numeric fractions. You may have learned at one point, some people learn keep, switch, flip, something like that, right? So essentially, when you divide one fraction by the other, you keep the numerator in this case, the first fraction, you keep it as it is, and then you switch the division to multiplication, and then you flip the other one over, right? So x squared over x squared minus 25. Don't be tempted to cancel those x squareds because they are not common factors. They're terms, but they're not common factors. We can only cancel common factors. All right, so we're going to turn the division into multiplication. We're just multiplying by the reciprocal, right? We take whatever's in the denominator, whatever we're dividing by, and we're turning it into a multiplication problem. All right, now we're just left with, same things we had before, which is we want to factor everything as much as we can. So we have x plus 5. We can't really factor that anymore. 7x cubed, that's fine. We know we have 3 factors of x in the denominator. X squared we have to leave alone, but we have a difference of 2 squares. So this is x plus 5 times x minus 5. And now you can see that we can cancel this factor of x plus 5. And then we can cancel these 2 factors of x, right? This is x times x, with 2 of the x's in the x cubed. So then we just have x in the denominator. Now we've canceled everything in the numerator, but remember, when I cancel something, this is really 1. I'm really left with 1. And so the numerator here is just 1. And then the denominator is 7x times x minus 5. And we're done. All right. Oh, here's a really ugly one here. So let's keep the numerator, right? So, but I'm going to go ahead and try to factor this. I know this, I can factor out an x up here. And then I'm left with x squared plus 4x minus 21. All right, so and then I'm going to factor that quadratic. All right, so I'm just going to go ahead and factor this because I know I'm going to need to anyway. All right, let's factor this x squared plus 4x minus 21. Factors of 21 that add to 4. So x plus 7 and x minus 3. We'll do it. And then I might as well go ahead and factor the denominator of the numerator as well. We have a quadratic, factors of 28 that add to 3. So we're going to have x plus 7. And what is it? X minus 4. All right. All right, so we're going to take the denominator, we're going to multiply by the reciprocal. So in this case, we don't have a fraction, so the reciprocal of 7x minus 28 is just 1 over 7x minus 28. All right, but I'm going to go ahead and factor the 7 out. So I get x minus 4. All right. All right, so now common factors. We have an x plus 7. And that's it. Darn it. Wow. It always feels so satisfying to cancel factors, but I don't see a whole lot here, although we can combine the x minus 4 times x minus 4 and make it x minus 4 squared. but there aren't any other common factors that we can cancel. So that's it. That's what we're left with. But it is a lot better than the original fraction for sure. All right, this is a good one, right? This is a difference quotient problem. This is essentially the difference quotient for 1 over x, for the function 1 over x. But we don't have to worry about that. What we need to do is just simplify this fraction. Now we have a difference in the numerator. Right? Difference is just adding the negative. So I'm going to deal with that first, right? I'm going to simplify the numerator first before I do anything else. And so what I'm going to do here, now I have an x plus h, right? I have a factor of x plus h in the first denominator, and the second denominator is just x. So I'm going to multiply the first fraction by x over x, right? That's just 1. And then the second fraction I'm going to multiply by x plus h over x plus h. Okay, and the other thing I can do is I know that I'm dividing by h, which is the same as multiplying by 1 over h. So I'm just multiplying by the reciprocal, right? That might make it a little bit nicer. And then I'm going to go ahead and work with the numerator, right? So I can take 1 over h times the numerator. What am I going to get here? I've got x over x times x plus h. And then I have to subtract x plus h all over x times x plus h. All right, so now I have a common denominator, and I can add those. I'm just keep this 1 over h here. And okay, so remember you have to subtract the whole numerator. All right, so I have x minus x and then a minus h. So what I have left in the numerator is just a minus h. And then in the denominator, that's just going to be x times x plus h. All right, now I'm going to multiply these two together. Now notice I have a factor of h and a factor of minus h, so I can cancel those and it'll become a minus 1. That's it. That's all I can cancel there. So when I simplify this down, it becomes minus 1 over x times the quantity x plus h. Okay. Now I could expand that out and say x squared plus xh, but it's fine. We'll just leave it that way for now. All right, one more here. Again, we have messy stuff going on here. We have a sum of fractions or a difference of fractions in the numerator and a difference of fractions in the denominator. Ick. Okay, well, again, just take it one step at a time. Just take it one step at a time. Let's think about combining the fractions in the numerator. We need a common denominator, so I'm going to multiply this times x plus 4 over x plus 4. Right? That's just 1. I'm not doing really anything to it. I'm just multiplying by 1. And this, whoops, that should be x over x, right? So now let's, if I distribute this, because really this is x times all of this, I have to distribute that x. So what am I going to get? I'm going to get 3x squared plus 7x. And then this is 7 times all of this, but it's a negative 7, right? It's a negative 7 times all of that. So I'm going to get minus 7x and then minus 28. What? 28. All right, all of that is over x times x plus 4. And then all of that is over the denominator. Now let's see what we can do for the denominator here. Let's try to simplify that. I have an x cubed and I have an x to the 5th, so this first fraction needs a couple factors of x. So I'm going to multiply by x squared over x squared. And then this will become 3x squared and then minus 28 all over x to the 5th. All right, still have a complex fraction, but now I only have one fraction in the numerator and one in the denominator. And I can simplify the numerator of this, the numerator of the numerator, right? I have a 7x and I have a minus 7x. All right, so I really just have 3x squared minus 28. So I'm going to write the numerator. 3x squared minus 28 all over x times x plus 4. And then I'm going to flip the denominator over. So I'm multiplying by the reciprocal of the denominator. So what that is just x to the 5th over 3x squared minus 28. Whoops, it looks like I accidentally wrote 2x and I meant 28. 28. Because, woohoo, look at that. We have a common factor of 3x squared minus 28. That just goes away. And it looks like we have a factor of x in the denominator and 5 factors of x in the numerator. So I can cancel that x with one of these. And so this will become a 4. The exponent becomes a 4. So what we have left is x to the 4th all over x plus 4. Nice. Much better. Much, much better than what we had before. So, all right. That's it for this skill. I'll meet you in the next video for the last skill, which is splitting expressions.